Hello to all editorial team. This presentation aims to show the main result of the research entitled Automated Tool for Conduction Emotion Analysis Study in Perception Survey, which was submitted for publication in the Bullet of Electrical Engineering and Informatics and will be published in the journal. The team is formed by Professor Gabriel Elías Chanchí Golondrino, who is the main author of this work, and by the co-authors Professor Manuel Alejandro Ospina-Alarcón and Claudia Estella Hernández. This is the proposed agenda for the presentation, which will include a brief introduction and contextualization of the problem, followed by a description of the methodology used, the result and the main conclusion of the project, and ending with the knowledge and reference used in this presentation. Introduction. Context and relevance of affective computing. The importance of affective computing in understanding perception. First, public comments in digital media provide valuable insight into user satisfaction and needs. Second, perception surveys analyze qualitative response to measure acceptance of product or service. Finally, advances in artificial intelligence and affective computing allow emotional state detection, data classification with machine learning, and visualizing emotional response for decision making. Proposed contribution and static validation. Proposed tool. Our tool enable us to analyze emotion based on Ekman's 6 emotion model, like angry, bored, excited, fear, happy, and sad. And our tool enables to process survey responses to generate emotional distribution. And from there, validate it with a perception survey conduct in the system engineering program of the University of Cartagena and analyze students' emotion about academic activities during COVID-19 confinement. The methodology we carry out for the development of this study has 4 phases. Phase 1, exploration of tools and technologies. Focus on the emotion analysis, Ekman's model, and statistical analysis. Phase 2, tool design, focus in the design of functional models for emotion extraction and result analysis. Phase 3, tool development, focus on the implementation of automated tools for conducting perceptions. And phase 4, case study, analysis of survey data collected and conclusion of academics activity during COVID-19.
Okay, with respect to results, first we have the functional modules of the tool. So this figure shows the 5 functional modules that comprise the automated tool. The key module, the emotion analysis module, the statistical analysis module, the graphical module, and a report module. The key module manages the tool's graphical components and handles user interface interaction events. The motion analysis module enables the extraction of the motion distribution based on Ekman's model using the parallel dots library. The report module allows the generation of CSV report with the distribution of emotions for each opinion of a given question. A statistical analysis model provides statistical measures for emotions extracted from question response, such as mean, standard deviation, minimum, and maximum. And finally, a graphs model allows visualizing the distribution of emotions for each opinion. Okay, with respect to the architecture of the automated tool, the following figure presents the software architecture of the proposed tool, which consists of three views: the view layer, the analysis layer, and the storage layer. The three layers encompass the functionalities described in the tool's functional modules. Okay, regarding the graphical interface of the tool, it's important to mention that it was developed in Python using the Teknik library and consists of four tabs: process question, statistical analysis, graphical analysis, and general analysis. In this slide, we can observe the first two tabs. In the first tab, the end user uploads the survey and the tool obtains the emotion distribution per question. In the second tab, the statistical measures for emotion based on Ekman's model are obtained. Okay, in this slide, we can see the other two tabs of the tool. The graphical analysis tab shows the distribution of emotions in all the opinions corresponding to the question analyzed. On the other hand, the general analysis tab shows the percentage distribution of emotions over the consolidated opinions associated with the question selected in the process question tab. Okay, in order to validate the relevance of the tool, a case study was conducted using the proposed tool, in which a survey with 5 open-ended questions was administered to 46 system engineering students from the University of Cartagena. The first question pertains to how the university managed various academic processes during the pandemic. The second question addresses how remote classes were conducted. The third question focused on how evaluation were carried out. The fourth question related to how students organized their time to complete their activities. And finally, the fifth question referred to whether the quality of education was affected by the so-called remote presence modality. Okay, as a result of the perception study conducted, this slide presents the distribution of emotions for each survey participant. Likewise, the emotions obtained were grouped into positive and negative categories, showing that in all cases the dominant emotion were negative. However, question 2 and 4 had a higher percentage of positive emotions. Recall that this question referred to how the classes were conducted and how students organized their time. Okay, regarding the specific results of the survey in question 1, we refers to how the university managed the various academic process. Angry was the dominant emotion with 25%, followed by excited with 20% and happy with 19%. Regarding to results of question 2, which refers to how remote classes were conducted, it's important to highlight that the emotion happy has a significant value despite angry being the dominant emotion. This indicates that students acknowledge the effort made by professors to conduct classes under this modality. Okay, regarding to question 3, which is related to how evaluation were conducted during remote presence, angry was the dominant emotion with 30%, followed by excited emotion with 18%, and fear with 15%. This reflects that it might have been an area of improvement on part of the university. Okay, regarding to question 4, which refers to how students organize themselves to complete their activities, although the dominant emotion is angry with 27%, the emotion happy with 19% stands out, highlighting the resilience of students during this period. Finally, regarding to question 5, which refers to whether the quality of education was affected, angry was the dominant emotion with 30%, followed by sad with 18% and excited with 18%. The results concerning negative emotion allow us to conclude that the quality of education was significantly impacted during this modality. So, in terms of the discussion, it's important to highlight that the proposed tool utilizes pre-trained machine learning models, allowing end users to leverage the benefits of affective computing without the need to develop or evaluate models. In the same sense, the tool goes beyond the polarity or sentiment analysis presented in 33, 34, and 37, enabling emotion distribution analysis based on Ekman's model. Okay, regarding the conclusions and future work, first, it's important to conclude that we proposed an automated tool for conducting emotion analysis studies, which allowed us to analyze the emotional perception of system engineering students during the COVID-19 pandemic. Likewise, the tool's main advantages include the automatic generation of reports and emotion distribution graphs, which facilitate decision making and reduce subjectivity in perception studies. Finally, as a future work, the main goal are to evaluate different emotion models and to test the tool in various application contexts. And in terms of acknowledgement, the authors express their gratitude to the University of Cartagena and to the participants of the survey considered in the case study. Okay, and these are the references that we considered for the development of this research. Thank you for your attention. We remain available for any question regarding the presentation.